How do you code one piece of software to work across multiple computers simultaneously? Even kids are learning how to do it. Let's hear about it on the K-12 Engineering Education Podcast. Distributed programming or parallel computing is quickly becoming the most important way of building software today. I'm Pius Huang, and my guest today is Dr. Ákos Ledeczi, an expert on distributed systems. Dr. Ledeczi is an electrical engineer, professor, and researcher at Vanderbilt University, who also specializes in computer science education. Several weeks ago, I spoke to him about NetsBlox, a project from his research group. NetsBlox is a visual or block-based programming environment that can help teach kids how to program software across networked computers or robots.
My name is Ákos Ledeczi. I am a professor at Vanderbilt University, computer science, computer engineering. My background actually is in electrical engineering, but I kind of switched to computer science a while ago.
And I know that you teach a lot of things and you do a lot of research as well. Some of what you do isn't just pure engineering. I know that you do some education work. Could you talk about some of that?
Right. So I started teaching introductory programming to freshmen about 12 years ago, something like that. And I experienced that rookies sometimes have quite a bit of problem to go through the initial learning curve.
Right.
So I've been teaching MATLAB because it's a required course for engineering freshmen. Mm-hmm. MATLAB is kind of a good tool for them to learn. So what I decided to do is actually the first 2 weeks of this course, I started teaching them Scratch. That's basically a much easier language to learn initially. And then after 2 weeks, once they got comfortable with programming in general, then we switched to the text-based MATLAB language. So that's how I got involved with CS education to begin with. But one of my research areas used to be and still is distributed systems and wireless networking, wireless sensor networks, and kind of learning how cool the Scratch programming environment is. And my background in distributed computing kind of gave me the idea to kind of marry the two and kind of open up a Scratch-like environment, open up the internet for a Scratch-like environment. So basically, we took the open source code base of Snap, which is just a variant of Scratch, but it's open source and it's done in JavaScript, and then we added distributed computing capabilities so students can write now not just standalone programs, but actually distributed programs.
One thing I wanted to ask you about was a lot of the people listening are actually teachers, elementary and high school teachers, and I think that they're familiar with Scratch. And I find it interesting that you use Scratch even at the college level. Do you find any advantages or disadvantages specifically with using Scratch to introduce students to coding?
So in my class, there is a wide variety of students. Some students have never programmed before, and some students already did quite a bit of programming in high school. So that's actually the challenge.
Sure. And
so I have to teach to the middle, but that means that some students find it boring, some students find it way too fast. Mm-hmm. And so I think introducing programming with Scratch for the first couple of weeks helped the students that have never programmed before. And so I think that was actually very useful for them. But as we'll talk about it, I'm sure, with the NetsBlox environment, that is, again, this extension of Snap and Scratch with distributed programming capabilities, it actually becomes really interesting for students who are already experienced programmers, but even relatively experienced programmers, because even them probably never wrote any kind of distributed programs.
Right.
That's just actually much more difficult than just regular programming.
Yeah, totally. So you go right into distributed programming kind of early on. As an engineer myself, I don't do a lot of distributed programming. So just for an overview for people listening, what's so special or different or challenging, I guess, about distributed programming versus more traditional sequential programming?
Right. So first of all, probably we should define what distributed programming is for your listeners who may not be familiar with the term. So probably the simplest definition of it is a distributed program that runs on more than one computer, right? But these days, pretty much 90% of the programs that we use on our desktop computers, on our phones, on our tablets are distributed, right? So if you watch a Netflix video, that's already a distributed program because you are watching it on your own computer. That's when the video viewer program runs, but it's being served from a server. The server sends the actual video data over the internet. So that's a distributed program. Many kids love to play, and adults, these multi-user online games, right? They play against other people. Well, that's a distributed program because multiple people are running it on different computers, and typically there is also a server somewhere in the cloud helping with that game. So basically a distributed program is a program that runs on more than one computer. And then that's where the trouble comes in, right? Because now you have to synchronize two or more programs running on different computers. They have to kind of stay in sync, and they have to exchange data with each other. And so these are two added complications that you don't experience when you just write a standalone program that runs only on your computer.
And you mentioned this visual programming environment called NetsBlox that you use to teach your students and teach other students, I guess, how to do distributed programming. You mentioned it's kind of this offshoot of Scratch and Snap. What is NetsBlox? Right.
So NetsBlox is based on the code base of Snap. The client itself looks almost exactly like Snap does, the client that's run in a web browser. We, of course, added a few new features to help with distributed programming. The main addition or the novelty is on the server side. So the server makes it possible for NetsBlox programs running on different computers to communicate with each other. And also the server makes it possible to get access to online data sources and the services like Google Maps, Street View, the movie database, StockVote, USGS, earthquake data, and lots of others. So then students can run programs that can write programs that use these data sources and communicate with other computers.
Cool. I saw that you have curriculum to teach these students how to make games, how to do some big data analysis, that type of stuff. Is that kind of what you expect when people use NetsBlox?
Right. Basically, I mean, two things that I expect. One thing is to increase the motivation and the engagement, right? Because once you are not kind of closed into your sandbox that is your own computer, once you can interact with data sources, live data sources around the internet, it just makes it so much more interesting and fascinating. So that hopefully student engagement is much better than with regular programming environments. And actually that's what we have found in our studies. Mm-hmm. So that's one thing that we expect. The other thing is that since most of the programs we use every day are distributed programs, teaching the basics of distributed programming is becoming basically a necessity. So these are kind of the two angles that we'd like to attack.
And do you have to have, can you go straight into learning distributed programming? Do you have to have a background in more traditional programming in order to effectively learn how to create distributed programs?
Well, I mean, what we do in all of our studies, we do not assume that the students already know programming. So basically, we start from scratch, if you know what I mean. But typically the first class that we teach is just regular programming, like, if statements, loops, variables. These are kind of the basic thing. But right, the second or the third class, you can actually already write a simple distributed program. In this case, what we typically do is an online weather app. So with NetsBlox, it's really easy to create a fully interactive Google Maps background, where you can, with the keyboard, you can zoom in and pan. So basically, you can look at the map of anywhere on Earth, and then you click on the map and you display the current weather data. And in order to implement this simple yet fun initial distributed program, you don't even need loops. You need to know if statements and variables. That's it, and you can write this app. And in fact, the youngest group we ever did this were fifth graders who already knew Scratch a little bit, but we just went to a science class and basically wrote this program together, and they really enjoyed it, and they were really engaged and really loved the end result.
That was going to be my next question. At what age do people really succeed with it? But I guess you've had success with really young students. What made you want to work with young students with distributed programming?
Well, it's kind of the other way around. We were approached by a local school. We were with them before at the high school level, and then they said that, look, I'm really interested, and I have this fifth grade science class. Can we do something? We are studying the weather, so can we do something with NetsBlox? And then my graduate student and I went there and then basically did this little one class weather app, and I really enjoyed it. But I have to admit that our main target audience are high school students.
Sure. And there are plenty of high school teachers who are listening, so I'm sure they'd be interested. I actually don't know of any other programming environments that are visual environments that are also connected to the internet in this way. Are there any other platforms that do this, that let you do distributed programming in a block-based environment?
Right. So one aspect, which is getting access to data, is already supported, definitely in Snap, but I think even the newest version of Scratch. But basically what you have to do is have the HTTP calls kind of inserted into your environment. And so it's possible, but it's cumbersome. And instead what we do, we introduce only two simple abstractions. One is what we call remote procedure calls, or RPCs. And basically that's similar to a function call, but that function happens to be running on the server. Mm-hmm. That's why it's called remote procedure call. And what we did is, as I said before, we implemented or we basically wrapped the Google Maps API, a weather API, and so on, all these web APIs on our server. And then through this RPC with a single block, we can access a simplified version of these services. So the students don't have to learn about ways to call web APIs, right. Don't have to worry about the API key or any one of these complications. They have one abstraction, a remote procedure call. And if they ever wrote a custom block and called a custom block, which is in visual languages is basically the function equivalent of a function, then they know how to use these RPCs. So it's really simple and really uniform.
That's really cool. Yeah, I saw that it was just a single visual block. It looks like any other function block, and you hide away all the complicated API calls, at least, which would be pleasant for me if I could use that as well. So you also have an educational program called Roboscape that I learned about through you a little bit, but I'm wondering if you could introduce that too. What is that?
Right. So before I go straight to that question, I need to describe the second distributed programming abstraction that we introduced, which is message passing. So basically, both Scratch and Snap has this concept of an event, which basically you can create an event and any other sprite or script can catch that event and react to that event. And so message passing is similar, except it also carries data. So it's not just an event, but it can have a data payload. And it can go to different sprites within your project, but it can also go to a different NetsBlox project running on a different computer. So RPCs and messages are these two abstractions. Now, back to your question about Roboscape. So the cool thing is it's just an additional service, just like Google Maps or Stopwatch. Okay, we call it Roboscape. And using RPCs, a combination of RPCs and messages, we enable students to remotely program wireless robots. So basically, the robot itself runs a kind of a generic command interpreter that we wrote in C, and it is open source also. And then the user's program just uses RPCs to send commands to that robot, and then the robot can reply with messages with tensor values or something like that. So basically now you can write these robot programs that still run in the browser and communicate with the robot. So it has a number of advantages. Probably the biggest one is now it's just as easy to program a robot in NetsBlox as it is to program a sprite, because it just runs in the browser. You can just debug it there and all that. So that's really cool, and it makes it really easy. So just to write kind of a manual remote control robot program so that you can drive your robot with the keyboard keys, like the arrow keys, for example. Mm-hmm. It's about 10 blocks of code, and you have a fully operational robot.
Okay. So the code is still on the computer, basically. It's not on the robot. It's just kind of responding. Okay.
Exactly. And that also enables another unique feature, which is we allow other programs, so other students, to intercept these wireless messages.
Right.
And so that basically enables them to kind of eavesdrop on your robot program, but they can also take over and hijack your robot. And that motivates cybersecurity, and it opens up the opportunity for us to actually teach them various cybersecurity concepts.
So I understand this Roboscape project involving the actual robotics combined with NetsBlox. You're kind of testing it out. Have you gotten very far in developing the curriculum and seeing how students of different ages react to Roboscape?
Right. So last summer, we ran 2 student camps with 24 students. They were mainly high school students. We had a few 7th and 8th graders. And it was very successful. We did pre and post tests, and it showed significant learning gains. And also the student engagement was really off the charts. Based on the experience, we kind of adjusted the curriculum. And in the fall, we ran an experiment or a study with a similar length with 10th grade high school students. And then now, this summer, we'll do a teacher camp, basically a professional development workshop, which will also be a 1 week long. And then we already have recruited about 46 additional students for two student camps also in June. So, and then we basically kind of formalize the curriculum. And so we have these curricular units described and detailed, and it's available on our website. And so anybody can adapt this. All the software is obviously free and open source. And right now we support one robot, the Parallax Activity Bot 360. We also added support for the Enki Vector, but unfortunately, I don't know whether you heard, they went out of business about 2 weeks ago.
But there's nothing really stopping your platform, NetsBlox, to be able to work on other robotics platforms, it sounds like.
No, basically the only requirement is if it has a Wi-Fi connectivity option, then we have our command interpreter implemented in C. I mean, there might be some differences between the platforms, so that program would need to be ported if there are differences, but that's really not a complicated piece of code, so that should be definitely doable.
So you mentioned that the students who were in this experience really got a lot out of it. They were engaged and they learned a lot. I'm wondering, why is that? Is it the platform? Is it the idea of distributed computing? Or is it also the teacher executing it? Was it you teaching them? How much of it is the topic and how much of it is the teaching?
So I wasn't the only one who taught. We kind of distributed the load between my graduate students and some of our additional researchers. So there were like probably 4 or 5 people involved in teaching it. And as much as I like to think that it was just me, I think it's mainly the fact that the tool itself makes it relatively easy to teach more advanced concepts at an accessible level. So that's one thing. The other thing is just the coolness factor. I mean, when we tell students that, look, in 2 days you'll be able to hijack each other's robots and attack them, and then you have to defend your own robot, their eyes just light up and they really want to get into it and really do it. And so that was clear, kind of. These are basically the 2 takeaways from our camps.
Cool. And just a real quick question about that cybersecurity aspect. Are there any technical things that teachers should understand before they can get into that advanced topic? Should they be already knowledgeable about cybersecurity and how to intercept Wi-Fi signals, that kind of thing?
No, definitely not. So obviously it's a week-long camp, and it's about 7 hours a day, and even for a week, that's kind of too much. So I think if we spread it out to 2 weeks, it would be actually better. So if you teach it like a few times a week, then it would be possibly even a full semester long topic. But even having said that, it's still basic stuff, right? So we cannot go into really advanced cybersecurity concepts, nor there is a need for that. I mean, you just basically want to tell the students that it's an important topic, and here are some of the basic things that you need to know. So basically, the things we teach is encryption, but really just the simplest techniques for encryption, and the need for secure key exchange, and denial of service attacks, and then the last thing we teach is replay attacks. So some of the basic techniques that are out there, just to basically raise awareness and teach programming and cybersecurity and distributed programming all at the same time. That makes it cool, interesting, fun, and then they also learn about these topics. But other than high school math, there is nothing really that's required.
Okay. Where can we find videos to see all this or learn more about not only Roboscape, but NetsBlox?
Right. So the website is netsblox.org. That's netsblox.org. And there is a menu at the top, and there is I think the help link will take you to a page where there are a number of videos, and under the Roboscape link, actually, that's where the curriculum is available. Now, the way it is available is as we basically just give a general overview, and if you want to get the actual detailed descriptions, you basically need a password. The reason we did that is because we don't want the students to download all the solutions and everything.
I see.
So teachers would have to contact me via email so that we can basically give them the password, but we just don't want to distribute it to all the students.
That's a good idea. I think that's going to be really helpful since not everyone can make it to Vanderbilt to go through all the training, but I'm sure a lot of people will want to investigate it. So let's say that someone does either go through your training or they learn a lot on their own. They try to implement this in their classroom and it's a success. Where do you see the future going after that? Like, what should students or teachers be doing beyond this curriculum?
That's a good question. So in addition to this specific robotics/cybersecurity curriculum, we have all kinds of other projects available on our website. So, for example, we have projects where you display historical earthquake data from anywhere on Earth. Again, you can write a Google Map background, you go anywhere, and then you click, and then you can display earthquakes for a given time period. I mentioned the weather application. I have a high school student currently finishing up a project. She is adding ice core data to NetsBlox, so students will be able to write projects where they study how the CO2 content for the last, I think, 800,000 years changed on Earth, and then they can correlate that with weather information and things like that. So there are a whole lot of opportunities to incorporate this into regular CS courses, but also science courses. Just like we did the weather app for a 50-day science class, you can do all kinds of other applications in different other science classes. And there is also another version of NetsBlox that we are working on specifically for teaching physics. It's called C2STEM, and it's available on c2stem.org. And there we actually created kind of a domain-specific version of the environment where students do not manipulate the X and Y coordinates of sprites on the screen, but they actually have to kind of implement a simulation, a physics simulation, how objects move in the real world. So we have gravity, and they can set speed and acceleration, and kind of there's a built-in simulator where each step of the simulation, they have to write their code, what should happen. And that basically teaches computational thinking and physics at the same time. And we have run many studies with that, and those look also pretty promising.
That's fantastic. Thank you. And it sounds like you have a lot of different projects. Just for the sake of closing up, I kind of like to ask this of all the engineers that I talk to. You have a ton of ideas. Where do you get your inspiration or your ideas to pursue all these different projects? What motivates you?
Well, so as I said, my background for the past 20 years has been distributed systems and distributed sensor networks. And now, basically, a kind of an offshoot of that is the Internet of Things. So this current revolution that's going on in an everyday life with the phones and the sensors and self-driving cars and everything it's really great. But if we don't try to teach the next generation early on how these systems work and how they can kind of learn how to contribute to this new industry, so to speak, then many people would be left behind. So kind of my inspiration is all these cool technologies that's out there. How can we make that accessible to kids at the high school or middle school level?
Akrosh, thank you so much. I think that's really inspiring to hear, and I appreciate your time.
All right, thank you so much too.
New coders and experienced coders alike who have never done distributed programming before may want to check out Dr. Ledeczi's NetsBlox platform and Roboscape curriculum. And if you don't have a Wi-Fi connection for your robots, or you're not allowed to use your school's Wi-Fi, don't worry. Dr. Ledeczi says you can always set up a Wi-Fi hub yourself with your phone or a Raspberry Pi server. Check this episode's show notes for links to this and more. Thank you for listening, and thanks to the donors to this show on Patreon who make this show possible. The K-12 Engineering Education Podcast is a production of Pios Labs, and if you want to help support Pios Labs, point your browser to patreon.com/Pios Labs. Find these links, episode transcripts, and more at the show website, k12engineering.net. Hey, it's Pius with some post-show notes. My colleague Rachel and I got together recently to propose 2 sessions at the upcoming South by Southwest Conference and Festival here in Austin, and we need your help to get there. If you go to panelpicker.sxsw.com and register and search for our session or our names, you can vote us up. Our session titles are called How Do You Build a Career in EdTech? And that's exactly what our session is going to be about. We want to talk to some of our friends who are K-12 teachers and who also have worked in the educational technology industry. And we want to ask them, how should people specialize in this field in the future? Because you don't go to school today and major in educational engineering or education with technology. And yeah, there's instructional technology as a master's degree sometimes, but that's only at a handful of places. So we are just opening up this discussion with experts about how do you focus on educational technology as a career. Rachel will be moderating, and I will help produce the segment, but we really need your help to get us at South by Southwest. If you go to the panel picker and upvote us, click on the little arrow pointing up for our session, that would be so helpful. Thank you so much.